How do muscle diseases create unique EMG sound patterns? Imagine listening to the electrical whispers of your muscles as they work or rest. Electromyography, or EMG, captures these signals and turns them into sounds that tell us a lot about muscle health. When muscles are healthy, their electrical signals have a regular, predictable pattern. But when muscle diseases like muscular dystrophy are involved, these patterns change in distinctive ways that help doctors diagnose the problem. In muscular dystrophy, muscle fibers gradually break down and are replaced by fat and connective tissue. This process affects how electrical signals are generated and transmitted. Instead of the usual smooth, consistent signals, EMG recordings show smaller, shorter electrical bursts called motor unit action potentials. These are often polyphasic, meaning they have multiple phases, which indicates that the muscle fibers are being remodeled or damaged. Because the muscle is weaker, the body compensates by activating more motor units at lower effort, leading to early recruitment of these small signals. This change in how the muscle activates creates a unique sound pattern on the EMG. Another key feature is abnormal spontaneous activity. Diseased muscles become unstable, and their membranes may leak or irritate, causing spontaneous electrical discharges. These appear as irregular bursts called fibrillation potentials or positive sharp waves. When listened to, they sound like crackles or irregular bursts, signaling ongoing muscle fiber irritation or damage. Certain muscle diseases, like myotonic dystrophy, produce a very distinctive sound pattern called myotonic discharges. These are repetitive, waxing and waning electrical signals that sound like a dive bomber or a motorcycle revving. These sounds are highly characteristic and help differentiate myotonic disorders from other muscle conditions. In long-standing muscular dystrophies, EMG can show a mix of different motor unit signals. Some may be short and small, reflecting new or regenerating fibers, while others are longer and larger, indicating reinnervated or surviving fibers. This mixed pattern reflects the ongoing cycle of muscle degeneration and repair. The pattern of EMG sounds can also vary depending on which muscles are affected. For example, in myotonic dystrophy, the muscles in the hands and face may show more pronounced myotonic discharges, while limb muscles might display different features. This variability helps doctors understand the specific type and extent of muscle involvement. Overall, these unique EMG sound patterns are invaluable for diagnosing muscular dystrophy. They help distinguish muscle problems from nerve issues and provide clues about the stage and severity of the disease. EMG is often used alongside genetic tests, blood enzyme levels, and muscle biopsies to confirm the diagnosis. In summary, muscle diseases like muscular dystrophy create distinctive EMG sound patterns because of changes in how muscle fibers generate and transmit electrical signals. These patterns reflected fiber degeneration, membrane instability, and disease-specific electrical discharges. Listening to these sounds allows healthcare professionals to better understand the underlying problem and guide appropriate treatment. Always remember, if you have concerns about muscle health, consult a healthcare professional for personalized advice.